Welcome to the Scalable Computing Podcast, joining you from Stanford in the heart of Silicon Valley. In this podcast, we discuss everything about cloud computing, machine learning, and large-scale systems. This season, you'll be joined by world-renowned guests from both industry and academia who have engineered and built some of the largest scalable computing systems in the world. Your host is Dr. Lamia Youseff, a scalable computing leader, one of the early engineers at Google Cloud, and former Microsoft and Facebook technology leader. This podcast is sponsored by Jazz Computing. Sign up for updates and new episodes at jazzcomputing.com/podcast. And without further ado, let me welcome your host, Dr. Lamia Youseff.
Hi, friends, and welcome to the second episode of the Scalable Computing Podcast. Today's episode is an extraordinary episode because we have an extraordinary guest. In our field, in computer science, it's quite rare to see a computer scientist who have made solid contributions to both industry and academia at the same time. Our guest today is one of these few computer scientists. Our guest today is Matei Zaharia. Despite his young career, Matei has made numerous contributions to both the academic discourse and the industry field of computer science. He has numerous publications that have been pivotal to the field. Additionally, in industry, he has made some very celebrated contributions to the open source community, co-founding Databricks, and even working with the biggest Fortune 500 companies in our world today. I got to hear about Matei's work through many of my colleagues at MIT and Facebook before getting to meet him at Stanford and joining his lab. I was pleasantly surprised to see how much dedicated Matei is to his students, to his research, and to the field in general. Today, Matei and I had a very rich conversation about many topics in computer science. We chatted about ApacheSpark, we chatted about contributing to open source software and managing the community. We chatted about MLflow and the future of ML operations. Join me in welcome Matei to our podcast today. Welcome, Matei. It's great to have you today with us.
Well, thanks a lot for having me.
In retrospect, when you look back at Sparks, what are the most 1 to 2 things that were super surprising to you when you look back, but also that was most risky or most challenging when developing the system?
Mm-hmm. Yeah, it's a good question. Yeah, so I think when we started out, this was a research project in a university, and we weren't really sure whether anyone would use it. So we learned a lot along the way with having people use it and supporting them and opening it up to more and more use cases as we went along and just trying to make it easier to use. So we learned quite a bit. I think what were kind of the hardest or more challenging things, I think definitely one challenge is like gathering feedback and really understanding what users are doing, especially when it becomes a larger project and there are many different types of use cases and there are people with different backgrounds coming into it and so on. So that's something that, we've always tried to talk to a lot of users, figure out what they're doing, figure out what people find difficult. We used to have these, like a list of all the error messages that people saw, and we would just go through the top few and try to eliminate the most common causes of errors, for example. And we're still doing things like that. But that's one of the hard things when you develop the system. You may not know what it's like for someone starting out with it. And I think that another challenge, but I think something that we did well is I think it's super important in this kind of infrastructure software to remain very compatible with older versions and allow people to actually write production applications on it. where, you can write an application and it's still running the same way 2 or 3 years later, maybe when you update to a new version of Spark. So a lot of, developers, certainly people who work in research, they don't ever have to do anything like this. But even people who work at a large web company, for example, and there you can go and tell every team, you got to upgrade by this date. But with an open source project with, millions of users who are writing production jobs, or like the whole purpose is that the job should not break, it should keep running. You can't do that. So we've been very careful in the design of APIs, the process of launching new things, and also the process of testing to make sure that things stay compatible. And I was really excited to see that the community actually always moved along to new versions of Spark, and they were all able to migrate to Spark 2.0, which was a pretty big change, and then 3.0 and so on.
Nice. So feedback from the community and integrating it quickly, as well as production application to make it scalable and resilient enough to be able to handle production application. I love these. Are they the same challenges that you have found with MLflow? I'm curious.
Yeah, it's a good question. So with MLflow, it was, we had learned a bunch of things from Spark, and it was just also a different setting, because MLflow, Databricks launched the project, and it was already, like somewhat sizable startup at that time. So people would kind of trust that, okay, this will keep getting developed and it will be good, and I can actually begin using it and relying on it. That's a bit different from a brand new project coming from a research lab, or even from a small company like the early days of Databricks. As a user, you would wonder, like, what might happen to this in a few years? What if I use it and then they stop developing it? So the setting is a little bit different. With MLflow, we focused a lot on just ease of getting started and on making it very easy to integrate with a lot of different tools. And these are things that we learned from Spark, or we did there, like supporting this ecosystem where people can use it with any machine learning library, any serving environment, and so on, is super important, because everyone has different needs there.
So that brings me to the question about the open source community. So that's like part of how an open source software continue to exist and continue to basically get developed and get new versions. Did you find it different managing an open source community over managing a group of graduate students, for example, a group of engineers at Databricks?
Yeah, well, it is different. And in fact, like, nobody really manages open source projects or communities. It's just meant to create this kind of collaborative environment where people can, agree on things to do in the project, and make sure that everything fits together and that it moves forward according to whatever standards they have. So it is quite different. You've got to collaborate with a lot of people, but it's very interesting because a lot of new ideas come in, and if you design the project the right way and you have the collaboration mechanisms in place, it's easier, it's possible for a lot of people to work independently on different areas that they care about in the project. So I think the good news there is that there are pretty established, governance practices. So things like, for example, consensus voting, and documenting everything very clearly in issue trackers, and having a process to discuss like what's in scope for the project and what's not, and to propose larger changes. So we looked around, and we tried to follow the ones that were successful in in other open source communities.
Totally. I don't know if you know the number of developers for each of them, number of contributors in the open source. I think in the thousands
roughly.
now.
Yeah, for ApacheSpark, I think it's at least 1,500. Maybe it's closer to 2,000 now. Just distinct people that have contributed to it. And in the last release, I think we had about 400 people who contributed patches. So in MLflow, I think the total is somewhere between 250 and 300, but it's a newer project.
Still, even at 300, that's bigger than most of the closed source, if I may say. projects that's being developed in the big cloud providers.
Yeah, that's true. Yeah, yeah.
A
No,
big
they're
team.
not. No, not everyone is full time, but it's still. Yeah.
Exactly.
The
Yes.
cool thing is that if people can go and contribute just one feature or one fix if they want to, and it might take a long time to be prioritized. Certainly, like the teams at Databricks that work on MLflow and Spark, like wouldn't be able to get through, all the stuff that is actually going in. Like they would never have the resources to just build all that themselves.
So that brings me to another question, which is Spark, being 10 years old, is a stable open source software nowadays. There must have been some turning points early in its lifetime. What are some of these decisions that you made, whether in the design side or whether at other aspects of its development?
Mm-hmm. Yeah, I think there are a few things, and it's hard to exactly attribute what contributed to what, but I think uh, uh, obviously, like the earliest one is actually working with users and supporting the early users and like learning from them to make the project better. So that was very hands-on, like thing where like I used to visit people every 2 weeks and talk to them and see what they're doing to learn what's happening with the very early users. Yeah, and after that, it moved into this form where it was easy enough to get started on your own, and so there were a lot of people starting to use it that we never had to meet in person that just began using it. But then you still wanted to gather feedback from those and figure out what's challenging for them. So I think beyond that, there were a couple of decisions that made it a much larger community. So one of them was actually trying to support data scientists. So instead of just engineers. So back then, all these cluster programming frameworks are for software engineers. You would write Java applications, or in Spark you would write Scala, which is nicer, and it's more interactive, but you needed a lot of background to begin using it. And we saw that a lot of people working with data had a different background. They had more like maybe domain knowledge in some area, or more statistics and math and machine learning knowledge, but less like just programming and software engineering. And we wanted to help those people actually directly query these large data sets and work with them. So we added support for Python and R interfaces to Spark. And we also worked a lot on understanding what operations folks need to do and how we can make those as easy as possible. And one of the things that led to is the declarative API to Spark, which is now the most widely used one, which is data frames in Spark SQL. So that didn't exist until 2014, that's when it started. So that's about like halfway through the lifetime of the project. And the nice thing about that is, unlike the Java and Scala original API, where you had to think a lot about performance and memory consumption and so on of your code, and you had to be like a Java programmer to get that right. In this one, you could just declare a schema and have some basic operations on the data, and things worked fine because we could optimize it underneath. So that was a big turning point, I think. And we've continued since then with more support for SQL as well. So moving even beyond data scientists to data analysts who just want to query something using SQL and use the Spark engine and maybe be able to call into code, like let's say machine learning code that the data scientists wrote. And that also is now a very large fraction of the users and an increasing fraction of them. So that's why in Spark 3.0, for example, about half the patches that went in were to Spark SQL, to things like ANSI SQL support and performance, because it's a very common way to use the system now.
What you said highlights a very important point in open source development, which is listening to the users. And it's amazing to hear that you went and visited users in the early days and talked to the community, as well as developing the API, the declarative APIs, and ease of the use of the system such that it makes it easier for them. Some people think that open source is just developing some code and throw it over the wall to GitHub, but it's interactive. So you go back.
Yeah, exactly. Yeah, but we did the same thing for MLflow, by the way. We also do it, of course, when we develop a product at Databricks. So, but it helps a lot to do that, to understand where it's going.
makes
But
it
I do
perfect
think
sense.
at a high level, though, one of the reasons that Spark became very widely used is because it really tried to expand the access to these big data computations, as I said. So it expanded it to data scientists who really didn't have any good option before, and to increasingly also to data analysts. Like now, a lot of data analysts want to work directly against, like, the fresh data that's coming into a data lake, and using Spark, they can go and query it and get the same kind of results that the data scientists and engineers are getting. So that's, I think, a major part. And and it's also, I think, the only platform where these can actually collaborate and hand off data between them in a very seamless way. In other places, you have to convert it, between 2 or 3 different systems.
That brings me to MLflow. So I know recently you donated the project to the Linux Foundation. Is that correct?
Yeah.
Would love to hear from you what other things you're doing.
Yeah. So MLflow came out of seeing, that more and more organizations are trying to are using machine learning successfully in production, and they want to increase the number of machine learning applications they have. And the challenge with that is that just operating these applications is very different from operating software, because you have to constantly feed them with new data and monitor them on a variety of metrics, and run experiments and test how these are doing, because the quality depends a lot on the incoming data and on the training process you use. So there was this emerging trend of companies building machine learning platforms, which are just some kind of software that that hosts and manages these applications. So all the big tech companies had internal platforms like FB Learner, which you worked at, so you know well about it, and TFX at Google, and so on. But also, every enterprise we talked with, was starting to build an ML platform. And we saw that there wasn't an open source one, and it makes a ton of sense to have an open source standard for this, because otherwise everyone's reinventing the same thing. And it's such a fast moving field, you just imagine having to maintain a platform and update it like every few weeks, maybe, with the latest release of PyTorch and the latest release of, like, Selden for serving and stuff like that. So it made a lot of sense to have this common one. And so we started that, and we did it because we want our product offering to have a great ML platform experience. And we thought you could get that with basically an enterprise like SaaS version of this managed one. And it worked out well. It turned out that a lot of companies did want to build on something common, even companies who are not, Databricks customers. So
Absolutely.
yeah,
Yes.
that's basically how it came to be. Yeah.
Okay, and given that you mentioned how quickly the project grew, as well as it's becoming today the de facto standard. When 2 years ago, when I was chatting with some machine learning engineers outside of the big companies, and basically they were telling me that they are using spreadsheets to track their different ML experiments. So MLflow definitely have addressed a very much needed gap in the market to be able to understand and to be able to help machine learning engineers execute and experiment very quick. Where do you see it in the next 5 years?
Yeah, I think there's still a lot to be done with machine learning platforms, actually, and there's a lot that I think isn't, people don't know the best design for it yet. So I think there'll be a lot to figure out. I think some clear things, like some things that we're working on now, include model management. So we launched this component, the model registry. It's kind of like a GitHub for models, where you can keep track of different versions or releases of the model. You can comment on them. You can have something like a pull request where you ask someone to review whether your model is ready to move to a production stage. And that's grown in usage quite fast. I think about half of our users on Databricks, at least, that use MLflow are using model registry also. and it launched like less than a year ago. So that's one kind of new thing. There's also quite a bit of work now on data quality and feature management and feature stores, and we see people building it. We have some reference architectures for building feature stores. There are also products out there that help you build a feature store, but that's another interesting area, is the data management. And I think in the long term, there's also quite a bit to be done with monitoring of machine learning applications, especially if you want to get into monitoring them for data drift or for fairness or things like that are more complicated to evaluate. And there's a lot of interest in doing that now. Nobody wants to run an application that makes errors there.
Absolutely. That tells me there is a exciting 5 years to come in the number of contributions and the number of things that will happen in this area in MLOps specifically. But changing gears a little bit. So as I was thinking, you're one of the most successful engineers and one of the most successful contributors to the open source community. What's your advice for a new PhD student or a new engineer that's just starting in this area?
Mm-hmm. Yeah, I think that's a good question. I think first of all, you want to join a great team, or like have a lot of people around that you can learn from. So that's one of the benefits of going to grad school, is usually there's like a very interesting community there of other students and faculty members, people in other departments, and so on. So I learned a lot from that. And then afterwards in industry, we also tried to have, like at Databricks, we tried to have a team where we keep hiring people that we can learn from, that are really good at the things that they're doing, even if it takes a long time to find someone like that. We want to do that. So I think that's one thing. It's also, I think it's also just interesting to read about a bunch of different areas. Don't just stay in one of them, because often there are some interesting opportunities at the intersection of those, or in a new area where something new is happening and there's room to actually have impact. So with something like Spark, it's not an accident that it was in a new area, which was this kind of large-scale data-intensive computing, and there wasn't much software there. If we tried to build something else, like whatever new operating system kernel or something, it's much less likely that you can do something that makes a meaningful difference to users versus what's already out there. You can do very interesting research, of course, like, don't get me wrong, but it's less likely to become a system or a product or anything like that. Yes, and I think like nowadays I have this kind of background with systems, and I'm also learning a bunch about machine learning, and that also opens up a lot of opportunities. And it takes a bunch of time to really get into a new area and to keep up with what's happening. But if you can do it, you can discover a bunch of stuff.
So that brings us to the last 5 minutes of our chat today, which is the lightning questions. So are you ready to start?
I don't know if I'm ready, but I'll try.
Awesome. Cool. So let's try. So the first question is, what is the most surprising application of Spark that you have seen so far?
Mm-hmm. Yeah, I think one of the coolest ones was early on. There was this, this neuroscientist at Janelia Farm Research Campus, which is a research institution, and they had these like transparent zebrafish, and they had these cameras looking at them, and they wanted to monitor like what's happening in the brain of that fish, like in real time as it sees, for example, as they show it a picture. So they had these cameras that would see basically which neurons are active because of the way they put some proteins in there that lit up when it did something. And then they actually hooked this up with like this Python application where you could see what's happening. So that was pretty crazy. We didn't anticipate anything like that, and it was very cool to see that.
Nice. I love that. Second question, most surprising application of MLflow is?
I think one really cool application that someone spoke about at Spark AI Summit is actually from Virgin Hyperloop One. So they're designing this Hyperloop transport system, and they need to run a whole bunch of simulations to, to figure out the right way to build it and the right way to manage the system. So there's a lot of experiments. They're not even necessarily machine learning experiments. They're just, like, let's imagine we set up the schedule this way, and imagine we build the train this way, and you have to run, maybe like tens of thousands of these and compare the results. So they're using it for experiment management in that much more like, general purpose experiment fashion.
Nice. Most impressive startup or open source software system I've seen recently is?
There are a lot of really cool kind of emerging things. I don't know what is most impressive. Definitely, I think the way that Kubernetes has, become a standard for just managing large distributed systems is quite interesting. I don't know if you consider that recent, but it's still happening. So, yeah.
Absolutely. So our next question is, the most important aspect of MLops that the community should pay attention to is?
I think it's data, actually, the most important aspect. There are some basics in MLops, like how do I get my, my code to run again in a production setting or something like that. But once you do those, I think the really difficult aspect is the data aspect. So because it keeps changing over time, and if it's out of sync, or if there are errors in it or whatever, very subtle problems can happen. And to make it worse, a lot of machine learning algorithms actually do kind of okay with corrupted data. So it can take a long time to even detect that something's missing. If you just delete a feature, like always set it to null, the algorithm might still do something okay. So yeah.
Totally, yes. The future of MLOps is?
I think, I don't know, bright. I think there's a lot to figure out, but it's clear that it's important, and it's going to enable teams to have a lot more of these applications. So a lot of teams we see, you put together a machine learning team, they do an initial application, they get it into production, and then they realize that now half their time has to be spent just babysitting this application and maintaining it. And they're all excited to build like the next 10 applications in their company, and they can't do that. So I think everyone is realizing that we need to make these easier to operate, like once you've initially created them.
Totally. Yes. So the last question, cloud providers are shooting themselves in the foot because?
That's a good question. I think, cloud providers as a whole are doing great. I think they're providing, really good platforms. So I don't know if I want to say anything negative about them. I would say, I guess, from a business perspective, I think they're still figuring out exactly, how to do partnerships and how to have like the equivalent of a, app marketplace and so on. They're working on it, but that's like one of the things that I believe, if they'd done earlier, like whoever does that really well first will be in a great position.
Love that. And on that note, thank you so much, Matei, for taking the time today to share with us your insights and to answer our questions on the podcast. Thank you.
All right. Thanks a lot for having me.
Sign up for updates and new episodes at jazzcomputing.com/podcast.